Hello everyone, I'm Yaogang. Okay, in this lesson, we will send HTTP requests. To send HTTP requests, we first include the header files. First, include these three header files here. The code is here. Note, if you include header files here, then any external reference to this header file will require including the HTTP module. Otherwise, if you only include this header file, it will report an error. Regarding these HTTP items, we can adjust the order. This way it looks better. Then in its CPP file, we need to do some includes. First, we will use JSON later. So let's put this JSON here. Then we will use some related information about EBO. Let's put this EBO here as well. Okay, alright. Then basically after the includes are done, let's go back here. Let's first check if the local explosion can pass. Because of the content you included, it's possible that this header file was not correctly linked in. Okay, that proves it was correctly included. Then let's start writing this file. So to send HTTP first, we need to do this first. Since we don't need request parameters for this, it's relatively simple. We'll just get the HTTP module first. This file is located here. It is a standalone module, specifically managing the HTTP module. Yes, so once you get it here, you can go ahead and create our HTTP. This is a smart pointer, then this module, and this HTTP. It contains many of these methods. We'll explain them when we use them. We'll also mention the ones we don't use. First, after getting this HTTP, we bind it to its completion callback. This method doesn't exist yet. We need to create this method. The signature of this method is like this. We put it here. We put it in the remaining HTTP here. This is the internal method. And this method supports overloading. This is the overload. Because the binding here is this kind of binding, this outdoor. Actually, this function, what is it used for? You can see. Let's see which one it accesses. It should be this one. This delegate. This delegate is actually, this delegate supports payloads. It is possible we can add our own payloads. Everyone should understand what this means. There are several delegates here. We mainly want to show you what can these delegates be used for. We found it in this ACB request that requires many delegates. This one has many methods to add content, throwing, etc. We will use them later. Then you add this header. Please fix the throw. It will also set some timeout parameters, etc. There is a request here. Obviously, you can get its progress. Yes, and this is when it retries. Then it will activate the delegate. We mainly, this place, podcast, we mainly look at it to complete this delegate. It should be here. Mainly this one. Cut it in. Then put it here. Okay, so this is when our request is completed. Yes, and there is another delegate I want to tell you about. See if there is time. It's about streaming. This streaming. So there is also a streaming delegate here. Sometimes when we do it, we better not use HTTP for streaming because it's quite troublesome. If you use streaming, EOTAA is more suitable. Yes, that's it. This should be the streaming one. Let's look at the format defined by this proxy. You can see it's a pointer plus a length. This is commonly done in C language. This scaleg will use streaming for both sending and receiving. Then you can get data in segments. After receiving them, you piece them together. This part is quite complex. We won't go into detail. Later, we will. And here is the HTTP module. It has a method like this. This module has a flash. We go to its header file, HTTP manager. Okay. Good. This flash method will block your process. Because our HTTP is asynchronous now, because it is here. We need to pay attention to this method. Of course, you need to get the HTTP manager. So this module manager, they all refer to different things. And our HTTP, if you call this method, so it will actually become a synchronous interface. For example, here, after it finishes executing, it will call here. And the timing of this call is during execution. It could be 1 frame or 10 frames later. But if you execute this flash method here, then it will keep waiting for this thing to execute. Only after this thing is done will it proceed. This will block our main thread. Designing it this way is also not a problem. it is generally not designed this way. Designing it this way means, at certain stages, you confirm that you want this HTTP back, regardless of whether it succeeds or fails. Only then do you continue moving forward. So that means we need to, within one frame, we need a B, C, D, then a B, C, D. They all have network requests. They must execute sequentially when completed. You would use this flash method, then tell the others. We generally wouldn't design it this way. We mainly write this for the flow. Mention this flash here, because you will use this later. This method, okay, so let's design this part. The URL of this request, just ask him which URL, and then his request. We set it to post, such a request. Then we set its header. The header is the type of his request. We set it to application, JSON. This part is actually not used, because this interface is relatively simple. As for the content, we just set it to empty, because we currently do not have, this thing does not need to pass the request content. Okay, then at this point, we send out this request. Good, so our request has been sent out. And when exactly will it come back? It might take a few frames. After it comes back, it will go to this place. This place can definitely be loaded. If sometimes, for example, you want to know what its GUID is, you can do it in this header. Here we set the header to something called xgid. Then put this guide here. Good. Then at this point you pay attention and observe, is this place request PTR, response PTR? Then you can actually get this thing. Use it to get header. Get all the headers. Then you can specify here to get a specific header. Let me write it down for everyone. We can do an experiment. Actually, when we bind here, it can also be overloaded. We can bind except, okay. Then the parameter signature here needs to be changed because we overloaded it. Okay, the main point here is to introduce it to everyone. So we'll add it, okay, and then here, normally you don't have to write it this way. Actually, then here we put this in. Actually, it should be more appropriate to do it this way. Try to use this thread in UE5. We all use this TER format to avoid some issue. Okay, so at this point, it can get our header. You can see for the second method, seek, we call it bank2. Then we call it bank. We give it bank1. We will be able to see the result in a moment. Okay, so because this involves an asynchronous step, we should not pass addresses here. We will copy everything. Okay, then in a moment we can get this result. And how do we write this part? First, let's add a log. Let's add a log first. Once we have added this log, we bring in another log. This indicates that we have received the asynchronous response for the request. And this part is just for demonstration. This part can be complex, so that is such code. You can completely delete it and the information we want to reply with. And before executing it, in the end, we will definitely release the resources. Right here, finally, we can release the resources. Then in the middle, we need to base it on the information we judge to make a decision. That is, whether it succeeded or failed. Before we judge the information, we need to have this function inside the reply next. We need to implement it, because we need to serialize it through this hierarchy. So how should this be written? The way to write it is also very simple. We directly access this. This part needs to be pasted. Let me check what the reason is. This interface can't have failed, right? Let me check this interface again. Okay, we looked it up again here. It should be that the interface has changed. We used the one below. This interface works now. You can say, okay, well, it sometimes updates here. That's what happens when you use someone else's service. So we recommend that everyone later will show you how to set up a service ourselves. It's just not stable at all, right? There's no way around it, okay? So, and then let's take a look. Then let's call this address. Let's change the URL address. It should be this project. Let's put this address here. You should take a look. This address should work. It looks a lot like the first address. Now it works again. A bit strange. I'll just ignore it. It might be an issue on our end. We'll put both addresses here. Use whichever one works for you. So the main thing is we need to encapsulate this structure. You can see the hierarchy of this structure is long. It looks like this. It's a string, and here is an array. Inside the array is a string, and here is a data. Inside data is a structure containing this T. Now let's encapsulate the structure. So I'll just copy it over directly. We explained this in detail in the previous chapter. How is this layer encapsulated? Let's first encapsulate the structure of the layer above it. Like this. Okay, the red guide here is what we need. Okay, this obviously corresponds to the API we just mentioned. Then this V, and here it returns to this information. And the most important thing is this. Let's bring another one over here. This is the specific timestamp. Let's remove this comment. Let's change the name. Here we'll add a sample. Then we put the timestamp here. And there is a T inside. Then let's take another look at this structure. This structure completely corresponds to this. This way it can be serialized over wrapped. Then the next thing we need to do is relatively simple. Let's go back to our CPP file. First of all, this request may not necessarily succeed. So we need to make this judgment to check whether it succeeded. What does this judgment mean? For example, first, this part needs to return a success. Then this HTTP status has an enum. This enum has several states. So this part also needs to be successful. And also this HTTP response code, it also needs to succeed. Then this is how it should be. Okay. You need to pay attention. Sometimes a null pointer can appear here. This direct pointer might be null. Why would it be null? It's because of your URL here. Your URL is written incorrectly. It can't find this address. So it's null here. Let me explain it. The reason is that it's null. You can simulate. You'll see that sometimes it's because the URL was written incorrectly. In this part, we did not judge this response. Sometimes I make such a judgment. But we didn't write it here because we are sure our URL is okay. Then we take this. It passes some data, converts it into this stream. This interface is to convert this content into fstream. Then here we print this fstream to see what it actually is. And then here we start parsing this JSON. So let's write the failure case first. If it fails, let's first choose failure. If it fails, we will concatenate the error message. So how is the error message concatenated? I win 听切. Then which action failed? What was he doing that failed? Then check the network. Because this kind of failure is usually a network issue. Yes. Then we will log the failure reason at the error level. And here we need to call that it failed. Okay, no problem. Then here we check if it succeeded. Then at this point we start using our transfer object. Because it's a blueprint reflection, so we support doing it this way. Here we pass it over, put it here to prepare a host. This is called message. The reason it's called message is because it directly corresponds to the message we are passing. This message, this info is used internally by UE. Then put this message here. Put it here. Okay, this way we parse it over. But this step may not necessarily succeed. Why it may not necessarily be successful? Because you might have written it incorrectly. We rule out the cause of code errors. Then it could be that its interface has changed. The review format it gave you has changed. So here, we still need to make a judgment. If it fails, then the reason for the failure here, then you will likely need to contact this reviewer. That is, you need to contact the author. Then the reason for this failure, we also record it, log it. Okay, this should be no problem. It's relatively simple. So what do we need to do to succeed? Success becomes clearer. Actually, this is how it's done. After success, we can get this time. This time is an F stream, right? It will give an F string. Then we need to divide this time by 1000. Yes, divide by 1000. Because this is its milliseconds, microseconds, seconds. Anyway, just do a time division. After dividing, we give this UTC time. convert it to a float Unix type space, full paging time. We also need to convert it to a time zone. Okay, that should be it. Then we record this native information. This information corresponds to its native information, and then this message. You can see we need to take responsibility for this message. So this message should be here. Okay. We give it our AAP message, copy it. Good. Note this row message, it is a receiver. This RP message is just a reserved field. Okay, finally we say it succeeded. Let's change this to a force. Okay, so we have written this interface for everyone. Next, let's call this interface. Let's see if it executes as we expected. Let me set a breakpoint here to check. Let's set a breakpoint. Now let's test it. I think we've basically covered everything. It will eventually release it here, because the execution here is already complete. And we have also copied the data in using the minute method. Okay, this timing part is a bit tricky. Everyone needs to be a bit more careful if you're not quite clear on what this timing is, because I've already got it working here. And here, if we have success, we just need to switch this TimeoutAPI. Let's execute it. Press 1. Okay, it's now executing this task, right? Then next, it goes to our activity. Then everyone, next step. Next step is here. Right here, our configuration. According to our configuration, it is Taobao. Then modify the API. Then we send an HTTP. Then this part is executed. And sending HTTP is right here. This half was actually skipped, and then this HTTP is returned. After it returns, you will find that this SACID. You can also see that both methods are fine. Of course, we recommend this one. You don't need to let it go through HTTP again, because it will increase bandwidth. If you want the server to receive this information, then you must write it to the header. Using this payload, it only achieves a payload locally. It does not go through the server side. So this half is written like this. Here we have some headers passed to the server. Then it's quite obvious. We are like successfully. You can see this JSON on our side. It is actually here. After the state train comes back, it looks like this. Then we parse it here. Blah, 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 blah. Parsing complete. Finally, let's simulate this output. You see, this time is actually normal because it's now 12:57:14. So roughly this very simple HTTP demonstration int year for everyone. Good. Okay. Right. So in this chapter, we will lay the groundwork for HTBC. Good. This has also been commercialized. Because you are accessing the interface on our commercial public network, then you integrate it into your own project and adjust it. But there are still some details. For example, sometimes we adjust the log level. Everyone should know this, right? Because we may lower or raise the log level or dynamically adjust this level. And this part is asynchronous. If you want it to be synchronous, you need to get the HT manager here. You can see the manager. It definitely has a method similar to get. Yes, find it. Ignore this one. Anyway, once you get this HTTP manager, you call its flash method. This way it can turn our asynchronous one into a synchronous one. Force it to wait here until it finishes executing before proceeding. Okay, let's stop here for now.